Hello everyone, I'm Yunjia from University of Wisconsin-Madison. We are working on transfer learning of query optimizers. This is a joint work with Yannis, Professor Jignesh, and Theo. We proposed a new problem of transferring query optimizers and present encouraging preliminary experimental results. We also conclude with some future directions in this new research area. The problem we are looking at is, given the database system A and B with a similar set of physical operator implementations, can we transfer the optimization module from the source system A to system B? Since the two systems may have completely different design in terms of programming languages, interfaces, which makes the direct transferring impractical, we actually think this problem as a transfer learning problem. That is to say, using a learned model to duplicate the decision-making behavior of the source optimizer and transfer that learned module onto the target system B. There are two phases in this transferring, learning and predicting. During the learning phase, some training queries are input into the system A to get the optimized execution plan for system A as training label. After training the machine learning module, the module is then applied onto system B. So on system B, during the prediction phase, queries are first get input into the learned model, and then the learned model output the optimized plan for that query, and then system B use that plan generated by the learned model for execution. Given this problem, one of the applications could be applying the query optimization module learned from a more sophisticated optimizer to some engine with not as advanced query optimizer or even no optimizer at all. An example could be transferring the optimizer from Postgres to Couchbase. Postgres is a popular database system and its optimizer has been developed and tuned for decades. However, Couchbase is actually a database system with a much shorter history, and its optimizer is not as much tuned as Postgres. To help optimize the querying performance of Couchbase before its optimizer is tuned, we could learn the optimization module from Postgres and use that optimization module to generate the plans for Couchbase. To verify this idea of transferring, we use this example of transferring from Postgres to Couchbase as our preliminary experiments, and the results are really encouraging as follows. We use the standard SSB benchmark queries to test the querying performance of Couchbase with and without a transferred model. In this figure, we can see that runtime of SSB benchmark queries without the transferred model, which means the original Couchbase. We set a timeout of 600 seconds for the queries. We see that 8 out of the 13 SSB queries time out for 600 seconds in the original Couchbase on our machine. However, if we use the transferred model, which is learned from Postgres to generate a querying plan for Couchbase, we speed up Couchbase by up to 47 times, and none of them times out anymore. Although there are some limitations of our experiments, this preliminary results still shows a very promising future of this new research area of transferring query optimizers. To conclude, we proposed a problem of transferring query optimizers, and we currently have some very encouraging results. As for the future directions, we could consider more complex query plan decisions, generalizing the learned model to different datasets, choosing the most appropriate source optimizer, or make the transferred model adaptive. That's all. Thanks for your attention.